Our mission was to make a prosthetic hand suitable for potential customers, as well as to make sure the hand functions properly for customer use. We used the engineering design process to guide our team in solving the problem. First, we identified the needs of our customers for the prosthetic hand. Our goal was to make the hand as cheap, durable, and effective as possible to please the customers. So our team began researching and developed the best solutions. We made sure to comply with the requirements of designing the hand under a cost of $50 and handling up to 40 kilograms of weight, as well as being able to grasp various objects efficiently and effectively. We constructed a prototype and then evaluated the design to improve the hand. And that's how we came up with our final design.
Final design. How it works. There will be a wire running from the tip of the fingers to the bottom lever. When the lever is pulled down at the base, tension is created by the wire, which will allow the fingers to bend and compress into a fist. Materials. Our CAD model is made from mahogany wood, which will provide great support and add some luxury. If we were creating the actual model for class, we would have used typical mahogany lumber for the base of the prosthetic, 3D printed the hand, both palm and fingers, from the CAD created. As to the connections, they are done by using invisible hanging wire, some screws for the base, and the use of a thick rubber glove to create a more stable grip when picking up objects.
Our CAD model is shown to the right. The total height of our model was 591.508 millimeters, or 23.2 inches. The height of the hand from the top of the finger to the wrist was 262.147 millimeters, or 10.3 inches. The width of the hand from the farthest left point to the farthest right point was 296.875 millimeters, or 11.6 inches. We decided to copy the dimensions or make the dimensions similar to one of my favorite basketball players, Kawhi Leonard. His width of his hand is 10.25 inches, and the height of his hand is 9.25. It isn't exactly perfect, but it's very similar to his hands. This will allow the hand to pick up bigger objects or palm a basketball. The depth of the hand was 20 millimeters. We created the hand super skinny so it could fit behind furniture if you wanted to pick something you dropped. The height of the finger was 146.225 millimeters, or 5.75 inches. The upper arm length, it was 220.598 millimeters, or 8.684 inches. The width of the upper arm was 56.554 millimeters, or 2.2 inches, and the width of the lever at the bottom was 100 millimeters, or 3.937 inches. We created the lever to be a little bit bigger, so if you have a bigger hand, your hand still could fit in the small compartment at the bottom, and not too big that's oversized for people with smaller hand. Some cool features that our hand has is that little circular area in the middle, which is a little bit lower than the rest of the hand, which allows things to fit perfectly inside the hand. Another cool feature that our hand has is that all the wires and cables are threaded through the arm so they're not seen. At first our hand was made out of steel, but our group decided that if we made a hand out of wood, it would be overall better. So our hand is made out of mahogany wood, which makes it look a lot better and more reliable.
For our design process, we came up with about 5 or 6 ideas of what our final product could be. However, we decided to narrow our options down because we thought some of them weren't practical enough, or we wouldn't be able to do it in time. So we came up with these 4, which were wooden hand, an Iron Man hand, 3D printed hand, and a cardboard hand. After we decided those 4, we were going to use a first and second level evaluation matrix for all of them to see which one was the best solution. And then after that, we would come up with our final design. For our evaluation matrix, we actually thought that we didn't need the Iron Man hand anymore because we didn't think it was going to be a suitable option. And we were just left with the 3D hand, the cardboard hand, and the wooden hand. And the metrics we used to measure each of them was the price of it, how expensive it would be, the strength or durability of each hand, and capabilities, which is pretty much how easy it would be to design each of them. So for the 3D hand, we thought it was definitely going to be the most expensive, so that was a downside. However, we thought making the design for it was going to be the most flexible, and the strength was about in the middle. Our cardboard hand was definitely going to be on the cheaper side, but we thought that it wasn't going to be strong enough for the weight test, and we didn't think that we could make a really good design with it. And for the wooden hand, we thought the price range was going to be in the middle between the cardboard and the 3D hand. It was definitely going to be the strongest, basically because of the material, and we thought it was going to be in the middle as well in trying to make a design for it. But in the end, we actually came up with a combination of the 3D hand and the wooden hand. We were going to use aspects of the wooden hand to have it durable enough to withstand the weight test, and we were going to use the 3D hand aspects to make a good enough design overall. So for our cost analysis, we looked on many websites, but we actually found the most cost-efficient ones on IKEA and on Amazon. The materials that we were going to use were an invisible hanging wire, and Elmer's wood glue. We were going to use screws, and obviously the wood. For the 3D printed hand part, we were actually planning to go on the mix to have it printed out, but we can't do that, unfortunately. And the cost listed on the left side is just the cost that we found on those websites. And on the estimated price of used materials tab, we were calculating how much of the item we were going to use. So an example would be like the hanging wire and the glue. We would buy both the items for around $12, but in reality, we were going to use about $6 worth of it. So we weren't going to use all of the item. We were just going to buy all of it to make sure that we had enough. And in the end, our total cost of the actual final product was $31.15.
Proposed testing. One of the most important tests we need to run with our model is a weight test. See if it can hold a 50-pound bag of rice for 30 seconds or more. Another important test is a function test. See if it can grasp, lift, and move an object such as a tennis ball, soda can, pen, and iPhone from one location to another. Another test we need to run is a durability test to test the materials, such as a drop test.
When our team was developing the prosthetic hand designs, we had to work within given constraints. The hand had to be at a low cost, lower than $50, so we were limited to the materials we could use to produce the hand, especially since good quality materials are usually higher priced. Another constraint we had was of time due to COVID-19. We weren't able to meet in person, and the project had to be done by the end of the semester. Since we weren't actually able to produce the hand, we weren't also able to know the actual weight of the model.